Ladies and gentlemen, welcome to quadratic modeling here tonight. We're going to deal specifically with maximizing area with a fixed perimeter, but this whole idea of modeling is a really powerful concept that the Common Core is going after, and it's the idea of, once we study the theory of some concepts, being able to take it to another level, take it outside the classroom and apply it to some real life scenarios. And I think tonight with the two examples we're going to tackle, we're going to get a really nice taste of just how powerful math can be once we take it into the real world. And so here, whether you have ever dreamed about being a farmer or not, regardless, I think tonight you're going to get just a real nice taste of how powerful this math is. We've got 500 feet of fencing to enclose 3 sides of a rectangular pasture. So we're going to put fencing here, here, and up this way. Assuming that no fencing is needed along the river here, what should the dimensions be in order to maximize the area of the rectangular pasture? So we want this region right here to be as big as possible. And it does make sense. If we want to put some cows or goats or whatever animals you want to put in here, the more area within the pasture, the more grass. Okay, so the first thing we're going to do to kind of get warmed up and get ourselves accustomed to the problem is we're going to complete the following table of values where a predetermined width is already given to us. And then once we fill in the table, we're going to kind of take a step back, study what we've learned, and make a prediction as to what dimensions will actually maximize this rectangle's area. So when they said that the width is 25, how much fencing do we still have left over? So imagine you're saying, I got 25 here, I used up another 25 here, and knowing that we have 500 to use up, how much do you still have left over? I think you've still got 450 feet left over. For my area, if I multiply my length times my width, or my 25 times my 450, I got an area of 11,250 square feet. Alright, now how about this? What if I used 50 feet for the width? 50 here, 50 there, that's a total of 100 already used. How much is left over? I've got 400 still left. If I multiply 50 times 400, that's 20,000 square feet. So it looks like the area got a little bit bigger. So in this case, I'd rather have a width of 50 than a width of 25. How about what if I set the width to 100? So I use 100 here, 100 here. That's a grand total of 200 used up. How much is left over? We've got 300 still left over. That gives me an area of 30,000 square feet. So that one's even bigger yet. So in this case, so far the best one I've got is a width of 100. How about a width of 150? Use up 150 here, 150 there. That's a grand total of 300. How much is left over for the length? I've got 200 left over. Multiply those two rascals together, and I got 30,000 again. Ooh, so I've got a tie right now for the best. But that's interesting. So far, going through the table, the values had, they got bigger, bigger, and then for the first time, they didn't increase. They kind of stalled out a little bit. Okay. All right, let's see. What if I set the width to 175? So I use up 175 here, use up another 175 here for a grand total of 350. That leaves me with 150 still left over. And if I multiply those two together, I'll get 26,250 square feet. So now I'm starting to drop again. Now I'm starting to decrease. If my width was 200, I use up 200 here, 200 here. That's a grand total of 400. How much is left over? I still have 100 feet of fencing left over. Multiply those two together. 20,000 square feet would be my area. So like right now, I'm thinking, it looks like my maximum is somewhere in this vicinity in here. Somewhere between 100 and 150. And so I'm going to mark that down as my prediction. Somewhere between W equals 100 and W equals 150. So I guess if I just split the difference, I guess technically my prediction is going to be to let the width be 125. So notice the dimension that we've kind of started each discussion with is the width. So in this particular question, they want me to express the width, the length, and eventually the area of the rectangle in terms of x. So we're going to write some algebraic expressions. And since we started with width, I'm going to say let x equal the width. All right. So I've got an x here and I've got an x there. Now the question is, how am I going to describe the length in terms of x? Now remember, the sum of these three sides has to be 500. So I'm thinking to myself, well, x plus L plus x equals 500. And if I was to combine like terms, we could say x plus x is 2x, and then solve for L. And L is going to be 500 minus 2x. Okay, so that's, I'm going to say we'll say length equals 500 minus 2x. Now, of course, area is going to be length times the width. So we could say area is going to be 500 minus 2x times the x. And we could distribute that x and make it 500x minus 2x squared. And that's one beautiful expression right there. Here's a really thought-provoking question. They said, consider the function a of x equals 500x minus 2x squared, which is the one we just wrote. We just changed the notation here so that we were using function notation on the left side. They want me to explain the meaning of a of 80 equaling 27,200 within the context of the problem. So first things first, what you'll notice they did here was they substituted an 80 for x, okay? And we know that by looking right here. Whatever's, of course, wherever that x used to be, they replaced it with an 80. And x, remember, x equals the width. So what I'm going to say here is that if the width of the pasture is 80 feet, okay, that means the length's got to be, the length must be 340, because I used up 80 on each of the widths, so that's 160. Subtract 160 from 500 would be 340. And the area is 27,200 square feet. And of course, that's what this final number is. That number, the output or your final answer, is going to be area. Alright, here's the coolest part about today's lesson is we're going to really get down to the bones of this. The table that we did earlier kind of gave me a good feel for what was going on, and it kind of helped me limit my options, and we made a prediction that the maximum area is going to be somewhere around a width of, somewhere between 100 and 150. But again, I'm just guessing, at that point. And here, the calculator is going to allow me to graph that function we just wrote, and it's going to help me come up with the most precise answer possible. And so the first thing is we get ready here, we're going to hit y1, and we're going to type in our equation. This is an equation that represents the area of the rectangle based depending on what the width is. Now, as far as our window goes, I tried Zoom Standard first, and what a disaster that was. That gave me absolutely nothing. So I said to myself, I got to use some common sense here based on the table that we were working with earlier. Now remember, x itself represents the width of your pasture, and if you consider some of the values that we've been experimenting with in the table, look back at your table, our widths, started off at 25 and then 50, 100, 150, 175, 200, etc. So I knew right there, just by looking at those values, my x max would be fairly big. So I went up to 500. And my min, you could just leave it at -10. It's really irrelevant. The x scale is also fairly irrelevant. If you want to change that to a 50 or whatever that floats your boat, be my guest. Now, the y's are also a little trickier. Think about what the areas were on that table, because of course area is equivalent to our y value here. Those areas were really, really big numbers. Now the biggest number that we saw on our table was 30,000, but we're also a little suspicious that maybe the maximum is actually bigger than that. So, you could go something like 35,000 or 40,000. I went with 50,000 just to be safe. And when you do something when you use a number that big, I'm going to make my y min -10,000 just to kind of keep things in perspective where I can see the x-axis. And then the scale, again, is pretty irrelevant. I went with the 1,000, but I mean, you could do whatever you want right there. And you go ahead and hit graph, and hopefully we're going to end up with something like this. All right. And of course, our goal is to find the maximum point right here. I'm going to go on my calculator. Again, I'm going to hit the trace button, but it's actually the blue letters above trace. I'm going to the calculate menu, so I'm hitting second calc or second trace. I'm using choice 4. The calculator is going to ask me to set a left bound. I'm going to establish my left bound in this vicinity right here. Hit enter. Move your mouse or cursor all the way over here to this side. Establish your right bound right there. Hit enter twice, and then all of a sudden it should print the max for you. And my calculator says that the maximum will occur when x equals 125 feet, and that would force the area, or the y value, to be 31,250 feet squared. And ladies and gentlemen, that's one big pasture right there. That's a lot of square footage, a lot of grass for those cows to munch on. Alright, we're going to experiment with one more problem here with a fixed perimeter. And what we have, our fixed perimeter in this case is 1,000 meters. We've got 1,000 meters of fencing to build two identical rectangular pastures that are adjacent to one another. In other words, they're side by side. They share this side right here. Determine what dimensions will maximize the total area of the two rectangles combined. And so what I'm going to do here is I got to establish, I'm going to say this is my width right here. And so I've got a couple of W's, in fact 3 of them total, and then my length will be this entire side up here total combined. Okay, so we're going to complete the following table of values just like in the last problem. This is going to give us a good feel of what's going on and just hopefully build some confidence here. So I think this one's going to be a little bit trickier to figure out, but so first things first, what if the width was 50? So we used up 50 feet of fencing here, we used up another 50 here, and we used up another 50 there. So at that point we've used up a grand total of 150, which if we subtract that from 1,000 gives us 850. Now you have to divide that 850 by 2 because you've got to use it on this side and this side. So 850 divided by 2 gave me a length of 425. I multiplied the length and the width together to get an area of 21,250 meters squared. Alright, so like we said, the whole process of figuring out the length's a little more involved than it was in the last one. So let's try it with 75. So let's say I used up 75 meters here, 75 meters here, 75 meters here. That means I've used up a grand total of 225 meters. Subtract that from the 1,000. That's going to give you 775, and then divide that by 2 to account for we've got to fence in 2 more sides. So we've got to, between these 2 sides, we've got to use up the 725. And that's going to give us 387.5. Multiply the length and width together, that's 29,062.5 meters squared. So notice that the area did get a little bit bigger there. Okay, let's try another one. So 100. So I used up 100 here, 100 here, and 100 here. That's a grand total of 300 I've already used up. That leaves me with 700 yet to play with, and that's going to be 350 on this side and 350 across the top. So 350 for my length. Multiply the 2 together. That's 35,000 square meters. Let's try 150. So I used up 150 here, 150, and another 150. That's a grand total of 450, which leaves me with 550 to play with, and I've got to use that up on these 2 sides. So 550 divided by 2 gives me, let's see, 275. Multiply those 2 dimensions together, 41,250. Wow, the area just keeps on growing. So at this point, we kind of get the feel that, well, the bigger the width gets, the bigger the area gets. But you're going to see this law of diminishing returns where that doesn't quite hold up anymore. And so let's say we used up 200 for all 3 widths. That's a total of 600 that we've already used up, leaving us with a leftover 400 to use on the 2 lengths. Divide that by 2. That's 200 for each of the lengths, and that gives me an area of 40,000. So now you're starting to see the area drop. So we're kind of guessing that the max is somewhere in this neighborhood, and for all we know, it might even happen right at the 150. Let's do one more just for fun. If all 3 of my widths were 300, that means I've used up 900 meters of fencing. I only have 100 left over, and so that means each of the lengths would be 50. Multiply those together, that's only 15,000. Wow, did the area just drop off like a rock there? So what is my prediction? My prediction in this case is that for right now, the best I can say is that the max will occur when the width is let's see, what was our biggest one? Our biggest one was right here. So we'll say a width of 150, and it's at least going to be in that ballpark right there. It's going to be really close. Now think about setting your window. We're kind of getting ahead of ourselves here, but these values right here tell you all the possible x values. So I'm thinking my x maximum is going to be at least 300. And then these tell you all your y values. So if this was my biggest y value, I know my y value needs to be at least, or my y max needs to be at least 41,000. So I'm going to probably overshoot that a little bit and make it 50,000 like we did in the last problem. Okay, perhaps the most challenging part of today, we're going to try to express the width, the length, and the area of the rectangle in terms of x. And so what I'm thinking is I've got, these are my widths that we established earlier, and then this whole side up here is my length, and of course we could say this whole side down here is my length. And I'm going to let x equal the width. And it seems to be a very standard first move, easy move to make. So I've used up x here, x here, x here. Now think about that. The grand total amount of fencing was 1,000. So I'm thinking off to the side here is that x plus x plus x plus length has to equal 1,000 meters, because that's how much fencing I have to play with. So 3x plus 2l equals 1,000. And then I'm just going to solve for l. First thing to do is I'll subtract 3x. So 1,000 minus 3x. And then I'm going to divide each term by 2. And that's going to leave me with length equals 500 minus 3/2 x. So we could say, we'll just rewrite that over here to be safe. Length has got to be 500 minus 3/2 x. The area, therefore, because we know that's length times width, the area has got to be 500 minus 3/2 x times x. We'll go ahead and we'll distribute, and that's 500x minus 3/2 x squared. And again, what a beautiful function that is. That's the one we're going to go ahead and plug into our calculator now. Now as far as our window goes, I think we're going to get lucky, and just because our two tables of values were so similar between the two problems, I think the same window is going to end up working out. So just to recap, I think my window was -10 to about, let's see, I think what did I have that at, 500? Yeah, and my x scale was about 50. Again, pretty insignificant when it comes to scale. My y min was -10,000, and my y max was 50,000, and the scale was, I think, 1,000. So hopefully that all works for you. Picture turns out to be very, very similar, just a little bit taller, fills up my window a little bit more than the last one did. I'm going to go find the maximum right here. So I'm going, just refresh your memory on how you got there. You hit second trace, which took you to the calculate menu, and we're looking at choice 4. We're going to set the left bound right here. We're going to set the right bound right here. Bang, bang, hit it twice. And your maximum turns out to be, now this was interesting, it wasn't quite what I expected. They said the width, or my x value, needs to be 166.6 repeating meters, and the area, or the y value here in this case, ended up being 41,666.6 repeating meters squared. So it was pretty close to my prediction. I think our prediction was around 150, so we're in that neighborhood, we're in that ballpark, and so that seems to be a very trustworthy answer right there. Tomorrow in class, we're going to revisit that problem that we flirted with a couple weeks ago, where we've got a flat piece of cardboard. We're going to cut some corners out of each side and fold up the edges, but we're going to do it for real life. We're going to start off with a large piece of construction paper. We're going to have a little contest as to see who can actually create an open top box with the largest volume, and we'll go from there. So it'll be a pretty challenging day, a little friendly competition amongst you and your classmates.